All right, question number 6 says, Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick. As shown in the diagram below, the troughs are rectangular based, open at the top, and have external dimensions of 300 centimeters by 190 centimeters by 160 centimeters. Show by calculation that the internal capacity of the trough is 8,081,000 centimeters cubed. All right, the first thing, we are given the external dimensions, and we are told that the wood that is used to make the trough is 5 centimeters thick. So we need to work out the internal dimensions. All right, so let us say we have external. And we have internal. Now, the external length is 300. Now, the internal length you have to take let us say that this is the internal length. We have to take 0.5 centimeters from each side. We have to take 0.5 centimeters from each side. The entire length is 300, but we have to take 0.5 centimeters, 5 centimeters from each side in order to get the internal length. The internal length would be 300 minus 10, which is 290 centimeters. The internal width, the external width is 190. Now, this is the width. Now, we need to take 0.5 from each side, 5 centimeters from each side. So in other words, to get the internal width, I have to take 10 centimeters from the 190. So it's 180 centimeters. The height. Now remember that the base would have been also 5 centimeters thick.
Whoa.
The base is 5 centimeters thick. So therefore, the height, the internal height, the external is 160. Take 5 centimeters for the bottom, you get 155. Now, the trough is in the form of a shape of a cuboid, which is a solid shape with a uniform cross-section. The volume, or we could say capacity, that's what we're asked for, the capacity, which is the volume, or internal capacity. All right, we didn't have to say internal, let's overstating it. Is equal to length times width times height. These are the internal dimensions, 290 times 180 times 155. And I am 100% sure that this is going to be 8,091,000 centimeters cubed. That's the internal capacity of the container. Next, we're asked to calculate the volume of the wood needed to make the trough. All right, so to get the volume of the wood, what I have to do is calculate, subtract the internal volume from the volume. I have to subtract the internal volume. All right, let me see if I can explain it. Imagine that this was like a block of cheese. A solid block of cheese. In order to make this block of cheese a container, I'd have to scoop out the inside, don't it? I have to scoop out the inside and I could make it into a container. It's a similar idea. So what I would do is I would calculate the entire block of cheese before I scoop it out, and then subtract the amount I scoop out, and what will be left will be the container. In other words, it's going to be the external volume minus the internal volume. So volume of wood would be the external volume, which is 300 times 190 times 160 minus the internal volume, which is 8,091,000. All right, if you put this in a calculator and press equal, you can just put it in exactly like that in a calculator and press equal, you're gonna get 1,029,000 centimeters cubed. So to get the volume of wood that was used to make the trough, you simply subtract the internal volume from the external volume. What will be left is the volume of wood. It says Farmer Brown must paint the internal surface of the trough, given that 1 gallon of paint covers approximately 280 centimeters cube of surface. We're to determine, okay, 1 gallon covers 1 gallon, given that 1 gallon of paint covers 280,000 centimeters square of surface, determine the total amount of paint in liters needed to paint the internal surface of the trough. All right, so it seems like he's sending us to do a lot of work. So much marks and given for 3 months. He's only given 3 months. All right. So I think in order to do this, we need to determine what's the total surface area of the trough. Now, the total surface area, because we need to know how much area we're painting. This trough has a total of what, 5 surfaces. So I need to find the area of the 4 sides, the internal area. So it's the perimeter, the internal perimeter, which would be 290 plus 290 plus 180 plus 180 multiplied by the internal height, which is 155, plus the area of the base, which is 290 multiplied by 290 multiplied by 180. All right. Now, if you just put that in a calculator and just press equal, put it exactly where you see it in the calculator and press equal, what we get is 197,000 centimeters cubed. All right, so one gallon will 1 gallon is equal to what? 3.79 liters. And this will cover 280,000 centimeters square. This should be square here. All right, so 1 liter will cover 280 divided by 3.79. And this is equal to 73,878.6 centimeter square. 1 liter of paint will cover that amount. Now let us see the number of liters we're going to need. Number of liters. It's going to be the total surface area, which is 197,000 divided by the area that 1 liter will cover, which is 73,878.6. So I would need a total of 2.68 liters of paint in order to paint the trough.